In the beginning, there was darkness, and then bang, giving birth to an endless expanding existence of time, space, and matter. Every day, new discoveries are unlocking the mysterious, the mind-blowing, the deadly secrets of a place we call the universe. In the universe, it's important to know your nearest neighbors. But how much do we really know about our corner of the Milky Way? In just the last few years, scientists have uncovered incredible secrets lurking in our own backyard. New moons, new planets, and new mysteries.
It's like there was a house in your neighborhood that you never knew was there.
Meet new neighbors who are just passing through.
There are planets that are wandering the galaxy aimlessly without a place to call home.
And old friends whose days are numbered.
It's conceivable that Betelgeuse will go supernova tonight.
Join us for a tour of the neighborhood we're only now getting to know. This is Our Place in the Milky Way. This isn't your neighborhood. Neither is this, or any of these. And it isn't even this. Looked at from a wider perspective, your neighborhood is a big cloud of gas. Astronomers say the solar system is moving through the local interstellar cloud, also called the local fluff, because of its low density and irregular shape.
The gases are mainly hydrogen and some helium. There are trace amounts of heavier atoms like carbon and oxygen and nitrogen that are just floating around the interstellar medium. We know that the heavier atoms in the interstellar medium are left over from previous explosions of stars as supernovae.
The local fluff is 30 light years long, about 180 trillion miles. It's inside a larger chimney-shaped gas cloud called the local bubble, also the remnant of an ancient supernova. The bubble is 300 light years long and lies in the inner edge of one of the spiral arms of the Milky Way. And that's our neighborhood. At least we think it is.
Our exact position in the Milky Way galaxy relative to the arms actually isn't known. The structure of the galaxy is not known in any real detail. Some people think there are 2 major arms, some people think there are 4 major arms. It's hard for us to determine the exact structure of our Milky Way, where all the arms are and so on, because it's kind of like a mouse being inside a maze. You don't get the big picture.
In almost any Earth neighborhood, you can determine your location very precisely.
Turn left in 30 feet.
But when you're dealing with something as big as the Milky Way, GPS isn't an option.
The galaxy is, 100,000 light years across.
Even exploring our local neighborhood involves a lot of uncertainty. But if we did have a galactic positioning system, it would probably locate us about midway between the top and bottom of the Milky Way, and about midway between the galaxy's outer edge and inner core.
Our solar system is about 26,000 light years away from the center of our galaxy.
According to one hypothesis, we have a very exclusive location.
There's one idea that only stars in a certain range of distances from the center of our galaxy are in the so-called galactic habitable zone, that is, able to have life on planets surrounding those stars.
It is just the right place with a star of the right temperature and a planet at the right distance for there to be a lot of liquid water on the surface where the chemistry of life began and evolved into us.
The overall range of the galactic habitable zone extends from about 13,000 to 35,000 light-years from the center of the Milky Way. The main part, where we are, ranges from 20,000 to 29,000 light-years from the core. Inside the zone, old neighborhoods have been destroyed to make a place we can call home.
Depending upon how you look at things, our local neighborhood, our local solar system, is actually a relatively safe place compared to what seems to be going on if you look at the universe in the large. In the early history of our solar system, it was a much more violent place when the material that formed the sun and the planets was still sorting itself out. There were all sorts of collisions and violent things happening that gave rise to this nice, calm, or relatively calm place that we have today.
We think that the earliest stars formed out of hydrogen and helium alone, but that over time, the stars work as these processors that create the heavier elements. This is important because when those stars eventually die and explode, these supernovae, or stellar death explosions, seed the galaxy and the material around it with heavier elements.
So for example, the carbon in our cells, the oxygen that we breathe, the calcium in our bones, the iron in our red blood cells, all those are heavy elements.
We know that the sun is at least a second or third generation star because there are planets around it. There are things made of iron and carbon and other heavier elements.
But the processes that led to life on Earth don't seem to exist outside the zone. Closer to the edge of the galaxy, fewer massive stars have exploded, producing fewer heavy elements.
Further out in the galaxy, you don't have as many atoms like carbon, nitrogen, oxygen, the atoms that are so important for the chemistry of life. So the habitable zone of the galaxy cuts off at a distance where you just don't have the heavier atoms to make life.
If the outer galaxy is a bad neighborhood, the inner area is even worse. Gravity from massive gas giant planets could tear us apart. And there are other dangers the closer you get to the galactic core.
Back in the times of Copernicus, we thought that we were the center of our universe. And even as we started to learn more about the heavens, eventually we still thought that we were the center of a galaxy. Now that we know even more, though, it actually turns out that we're lucky we're not in the center of the galaxy.
At the center of the Milky Way, sucking matter and even light into it, is Sagittarius A star, a black hole nearly 14 million miles across, with a mass 3.7 million times that of our sun.
Yeah, the galactic center has a black hole in it. It gives off a lot of radiation, enough to fry life as we know it. So you can't be too close to that. Then there are other regions in the galaxy that are also probably not so great for life because there's just so much radiation from nearby really hot O-type stars.
O-type stars are giants. They're hotter than the sun, 10 to 50 times as massive, and throw out titanic amounts of ultraviolet radiation. With these stars, you don't worry about sunburn, but extinction.
It's probably not easy to survive in an environment where you're in a tight cluster with a lot of O-type stars.
O-type giants can destroy planets before they form.
The radiation from these stars is so strong that it actually sweeps the material away from these newly forming would-be planetary systems and rips it out of the orbit of their stars.
If you want proof, look at the Rosette Nebula. It's 5,200 light-years away, far outside the local bubble. But it shows what O-type giants could do to our neighborhood. A 2008 study by the University of Arizona of 1,000 stars in the nebula found star after star had been made barren by being too close to a blue giant. So what's a safe distance from the radiation of an O-type giant?
Well, if you ask me, you can never be too far away from a giant. If you're life like us here on Earth, we're used to our fairly tame sun. You want to be probably at least tens of light years away, maybe more than that. Really, just don't get too close.
Like a city between a desert and an ocean, our corner of the galaxy thrives between two different, inhospitable regions. With the elements of life and without the threat of intense radiation, it seems like our neighborhood is literally the only place to live. But is our place in the Milky Way really so exclusive?
The idea of the galactic habitable zone is that if you're too close to the center of the galaxy, there's all these crazy things going on and it tends to kill off life. To be honest, I'm personally skeptical of the idea because I think that life can happen in all sorts of environments, or at the very least, we don't know. So we should be open-minded. It's possible that our kind of life can only live in this galactic habitable zone, but elsewhere there could be other kinds of life that we would call extremophiles. On the other hand, they would call us extremophiles.
One thing is certain. In our neighborhood, we have a sun that, unlike a blue giant, protects us from danger and destruction in ways that we're still learning about. That protection may be invisible, but if we lose the sun's protection, our neighborhood could be doomed. Our place in the Milky Way seems pretty peaceful because, like a lot of communities, we don't give much thought to the 24/7 security systems that keep the bad stuff away. Many cities on the edges of rivers or oceans have dams and levees to protect them from floods. If the dams and levees fail, disaster. We've got threats and defenses on a galactic scale, too.
Space is filled with radiation, known as cosmic rays. Cosmic rays are bad for us in the same sense that nuclear radiation here on Earth would be bad for us. Because high-energy radiation tends to disassociate carbon bonds, which is what we're made of. What you're really doing is damaging your DNA, and there's a potential there that you could start to have mutations based off of that.
Some mutations can help a species survive or lead to extinction.
There's no evidence that cosmic radiation has really negatively impacted Earth in the past, but it's nothing that you want to play around with.
Our neighborhood's prime defense against cosmic rays? Magnetism.
We have this zone of protection in our neighborhood. Of course, the Earth has a magnetic field due to how things move around in the core of the Earth. The Sun also has a powerful magnetic field, and it also has the solar wind. These phenomena actually generate ways of protecting us from things that come from outside the solar system.
The Sun's magnetic field is twisted by the solar wind. Streams of charged protons and electrons that shoot out of the Sun at 1,000,000 miles an hour.
Then the particles that live in the solar system between the planets actually stretch the lines of the magnetic field around in complicated patterns.
The solar wind carries the magnetic field more than 3 times farther out than the orbit of Neptune. But 9 billion miles away, at a place called the heliopause, the solar wind runs out of steam and slows to almost nothing. As it slows, it twists the Sun's magnetic field into a barrier against cosmic rays from interstellar space. This is the heliosheath.
If it wasn't for the heliosheath, these cosmic rays would actually pour into our solar system all the time. The heliosheath acts as a kind of shark cage for these incoming cosmic rays that might otherwise influence our planet.
Some do come through, but they don't come through as strongly as they would without that protection.
It used to be thought that the heliosheath was a rather elegant barrier made of flowing curtains of magnetic force. But recently, enter Voyager 1 and Voyager 2, probes sent out from Earth in 1977. In the early 21st century, these disco-era devices sent back information indicating that the sun's magnetic field lines don't flow smoothly together. They break up and reform into violent magnetic froth, and each bubble in that froth is 100 million miles wide.
We used to think that it was a smooth, nice barrier between them, but in fact it's a roiling place with all sorts of bubbles and patterns. I think there's always been people who think the universe is more elegant than it is, and people who think it's more violent than it is, and we're always surprised one way or the other. The truth is that some aspects of the universe are quite elegant, and in other aspects it's quite a mess.
Where are the elegant areas of our galactic neighborhood, and where are the rough parts? It can be hard to tell with all that gas and dust in the cosmos.
It's sort of like looking here. Behind me is Hollywood. There's even a landmark there, the Capitol Records building. You can barely make it out. And even beyond that, there are some hills that are even hazier. It's because there's stuff in the air that blocks the view. The hill itself obscures my ability to look beyond it. And that's kind of like the dust in very dense molecular clouds. When you hit a big wall of a dense molecular cloud filled with dust, you can't see anything.
When we explore our galactic neighborhood, what we see depends on how we look at things.
One of the things we've learned through the history of looking at the sky is that every time you look in a different way, you see new things. And looking at the sky a different way often simply means looking in a different part of the electromagnetic spectrum. As we look up into the sky with our eyes or with the aid of optical telescopes, in the visible part of the spectrum, we see the night sky, and there's a lot to see, but it's only a fraction of what's out there.
Some space telescopes see through cosmic dust with infrared vision, similar to that used by commercial infrared cameras.
I've brought with me this plastic bag. And when I put my hand inside of the bag, you can't see how many fingers I'm holding up. With the infrared camera, you can see the heat coming off my body. So my face, which is warm, is red and white, but my hair, which is cool, shows up as blue. So with the infrared camera, you should be able to make out how many fingers I'm holding up, even though you can't see through this bag. That's how astronomers peer through cosmic dust when they want to see things that are hidden from sight. For example, stars being born are very warm, but they're obscured by dust shells. With infrared, we can see them.
Certain objects are transparent or opaque depending upon the frequency of the light that's trying to get through them. And so, in fact, something that's getting in the way, like a lot of interstellar dust or gas, is getting in the way of what your telescopes can see, are actually invisible in another part of the spectrum. You can see what's behind.
With infrared and a multitude of other wavelengths at our command, we've discovered a lot of neighbors we didn't know we had.
There's a whole array of instrumentation which is exploiting that lesson that if you look in a particular part of the spectrum, you see the sky in a very particular way.
From what we've observed, it looks like some old neighbors might have helped life form on Earth, while some newer neighbors may be planning to wipe us out. As we've explored our place in the Milky Way, we've met a lot of interesting new neighbors. But there are good neighbors and bad ones.
Good neighbors are, for example, objects that are in predictable orbits, moving around, doing their own thing, minding their own business. We can look over and wave to them, but they're not going to do something sudden or dangerous to us. The bad neighbors then would be things that may do something unstable. They may do something that could affect us in a way that we can't predict when it's going to happen. So that might be when a star dies and explodes. Or it might be when something collides and bounces off something else and comes spinning in our direction. So classifying things roughly into good neighbors and bad neighbors is really a classification into predictability and unpredictability, or violence and non-violence, if you like.
Sometimes a good neighbor will bring a moving-in gift. That might have happened to us billions of years ago, as the Earth was still cooling and forming out of recycled material from a recycled sun. We might have received a gift that changed everything.
The early Earth was very hot, and probably any original surface water evaporated away. So we think that quite a bit of the water may have come from either comets or icy asteroids, or both.
One of the theories about how we might have gotten so much water here on Earth is from icy bodies in the outer solar system left over from the formation of the sun and the planets, crashing into our inner solar system where Earth lives and delivers some of that water.
According to one recent theory, about 4 billion years ago, the gravity of gas giants like Jupiter sent icy asteroids slamming into Mars, Earth, and Venus. But only on Earth did the ice penetrate into the mantle. The water softened the Earth and initiated a titanic process of plate tectonics, which led to the emergence of continents and oceans. And what of the life that formed in the oceans? Did organic compounds necessary for life also splash down from space? In rare meteorites called carbonaceous chondrites, scientists have found organic compounds like those that helped form life on Earth. These compounds are similar to what's been collected from many different sources, including Antarctic micrometeorites, interstellar dust, and comet samples acquired by NASA's Stardust mission in 2005.
The origin of life involves a long series of reactions with many different organic molecules being just ones with carbon in them. And it's possible that different circumstances are needed to make the different organic molecules. Some of them might be made here on Earth, but others might be easier to make out in space, and then bring them here to Earth on asteroids or comets.
It's possible that without extraterrestrial gifts from our neighbors in space, life on Earth might never have happened. Milky Way neighbors may have helped nurture us, but the Milky Way has things that can kill us as well. With something like this, an orange dwarf named Gliese 710. It's about 60% as massive as the Sun, and is currently just 63 light-years from Earth, and getting closer.
Gliese 710 appears to be heading pretty much straight toward the solar system.
As an orange dwarf approaches the solar system, it becomes more and more significant. When it's about a light-year away or less, then it becomes very important.
Almost exactly 1 light-year away from Earth is a huge region of icy objects called the Oort cloud.
The Oort cloud objects could turn into comets if they were to come close enough to the sun, but usually we don't see them at all because they're so far away from the sun.
Billions of potential comets are waiting for something to give them a gravitational push. Something like Gliese 710.
It'll start intersecting the Oort cloud, or at least gravitationally disturbing it, in something like 1.3 million years.
If Gliese 710 gets close enough, its gravity could turn harmless chunks of ice and dust into rampaging comets launched at us. The results for Earth could be devastating.
At that point, there could be a huge onslaught of comets into the inner solar system that could lead to another mass extinction. We don't know that that'll happen, but it could happen.
Astronomers say there's an 86% chance that Gliese 710 will barrel right through the Oort cloud.
So if the orange ball was like an orange dwarf, like Gliese 710, and the pins were the Oort cloud, this is one thing that could happen.
All right, but here's something else that could happen. There's a 14% chance that Gliese 710 is just going to pass right by outside the Oort cloud, not coming inside it at all.
But even without a direct hit, the effect of the star's gravity could disrupt at least some comets and send them straight for us.
So the star could knock just a few comets toward the inner solar system.
And all it takes is one comet to hit Earth to cause a catastrophe.
We've got more than just Gliese 710 to worry about. There are more than 150 stars close enough to disturb us within the next 2 million years.
The stars in our Milky Way galaxy are all gravitationally bound together. So they're moving in various directions, overall a rotation around the center of our galaxy, but not all the orbits are exactly the same. That means from our perspective, a given star might be going away from us or toward us.
And NASA estimates there are more than 20,000 near-Earth asteroids more than 300 feet across. Like 2005 YU-55, which in November 2011 came closer to the Earth than the Moon. It might come even closer in 200 years. How bad would it be to get hit by a rock like that? Think about Nagasaki at the end of World War II and multiply by 4. As we've searched our corner of the Milky Way for other neighbors, bad and good, we've found some very unexpected things. We now have evidence of stars cold enough to touch and planets straight out of science fiction. Exploring our place in the Milky Way has turned up one surprise after another.
It's like there was a house in your neighborhood that you never knew was there and that you've suddenly discovered, but is just down the block.
Take Alpha Centauri, the brightest star in the constellation Centaurus, and after the Sun, our nearest neighbor star, 4.3 light years, or 25 trillion miles away. In the 17th century, astronomers announced that Alpha Centauri was really 2 stars. Then in the 20th century, it turned out to be a triple system.
Alpha Centauri A is very much a Sun-like star, nearly exactly the same mass as our Sun. Alpha Centauri B is a little bit less massive. The third star, Proxima Centauri, is an M-type star. It's a very low-mass star, having perhaps only 12% the mass of our Sun. It is so faint that we can't see it with our unaided eye.
It turns out that other very well-known neighbor stars are also multiple systems. Sirius, just 8.6 light years away and famed for thousands of years as the brightest single star in the sky, is really a binary star.
Most stars are less massive and smaller than our Sun, and most stars are in binary systems. In both respects, our Sun is a little bit of an exception.
The majority of stars are red dwarfs or brown dwarfs. Red dwarfs make up 70% of the stars not only in our galaxy, but in the universe. And so, even though we orbit our Sun and we tend to think of it as the iconic star, really, the red dwarfs are far more common.
As for the brown dwarfs, these are neighbors we weren't sure existed until the 1990s. They're not quite stars, but they're not planets. Oh, And they're not really brown either.
The brown dwarfs are some of the most mysterious denizens of the solar neighborhood because they're really very, very cold. And they're very dark, and that means that they don't give off a lot of light, and they're very difficult to see.
In 2011, one of NASA's space telescopes, the Wide Field Infrared Survey Explorer, or WISE, found a series of brown dwarfs right in our neighborhood, between 9 and 40 light years away, with surface temperatures once considered impossible.
One of these brown dwarfs that we found is actually so cool that you could touch it with your hand. It's only 80 degrees Fahrenheit, the same temperature as a really lovely day out here on Earth. And so, who knows what else we'll find? The more we look, the more we see.
Why are stars so many different colors? That's what Anna Kay of Baton Rouge, Louisiana, texted to Ask the Universe.
Anna, that's a really interesting question. Basically, stars have slightly different colors because they have different surface temperatures. Cool stars like Betelgeuse look reddish, and they have temperatures of only 6,000 or 7,000 degrees Fahrenheit. The hottest stars like Rigel appear bluish, and they're upwards of 20,000 degrees. Then there are stars like the Sun with temperatures of 10 or 11,000 degrees, and they look white. Now, the Sun looks yellow when it's setting, but that's because of atmospheric effects. Its true color is white.
There are more than stars out there. We've discovered hundreds of neighboring planets inside and outside the local bubble.
We have discovered a lot of exoplanet candidates through a mission called Kepler that is looking at essentially little eclipses when a planet moves in front of its parent star and then out, and the light dips a little and then goes back up.
It's very difficult to see, analogous to watching for a single light bulb going out on the Vegas Strip. But Kepler is capable of doing these measurements so precisely that it's able to find even planets as small as our own Earth around stars like our Sun.
The first exoplanet we discovered was only about 15 years ago, and it was very much like we were the only house on the block, and we saw the first neighbor putting up their house. And ever since then, the entire neighborhood has grown. You built up communities of other exoplanets out in our local neighborhood.
As far as we know, our nearest planetary neighbor outside the solar system is just down the street, 10.5 light years away, orbiting the orange star Epsilon Eridani.
This planet isn't exactly something that we could go visit and expect to find life. We think that this planet is more equivalent to a planet like Jupiter in our solar system, a big ball of gas, which, as we understand it anyway, isn't a great place to look for life.
A little farther out, about 200 light years, is another surprise. A planet that looks like something out of a Star Wars movie.
Just recently, the Kepler telescope discovered a planet that orbits two suns, and this is a planet called Kepler 16b. So this planet, even though it has similarities to Tatooine, isn't exactly like Luke Skywalker's homeworld. It's actually a planet that's icy and gassy, more like Saturn than our own Earth. Now, we were never sure prior to this discovery whether you could have a planet that actually has two suns. And so, now that we found one, we know that these are possible. And that's really interesting because it means that these binary systems are good places to look for planets.
In 2011, astronomers unveiled a new kind of planet in our neighborhood, the homeless.
There have been some indications that there are planets to be found that are not in orbit around their parent star. They started out in orbit around their parent star, but somehow got ejected from their solar system, and now they're wandering the galaxy aimlessly without a place to call home. So one wonders if pretty soon we'll have another new definition that encompasses those bodies that used to be planets and no longer have a parent star.
I think it's still valid to refer to these ejected bodies as planets because planet is the Greek word for wanderer, and they are certainly wandering through deep space.
We've even learned new things about our solar system neighbors. In the summer of 2011, The Hubble Space Telescope took the first pictures of the dwarf planet Pluto's previously unsuspected fourth moon.
Now you might wonder, Pluto's not all that distant. Why did it take us so long to find a fourth moon? Well, it's because it's very, very small, only 10 to 20 miles in diameter, so it's very faint. It reflects only a little bit of the sun's light.
The new moon is probably a frozen, lifeless world, like Pluto itself. So far, all of our newly discovered neighbors have been too hot or too cold to have any possibility of our kind of life. But the search goes on.
So even though we haven't done it yet, we're at this point where our technology has caught up to our needs, and we're actually going to be able to start finding those planets like Earth in the really near future. However, being able to determine whether they would be supportive of life is a much more difficult task.
None of the exoplanets we've discovered in our corner of the Milky Way pose any threat to us. But what about some of the stars out there? Could some of them die and take us with them? Our place in the Milky Way has a lot of pluses. We're right in the zone for life to form. Our closest star protects us from dangerous cosmic rays, and most of our neighbors don't disturb us. But neighborhoods can change. If a fire destroys a nearby home or business, your home could also be damaged. So imagine what might happen when a star goes out of business as a supernova.
That means they'll explode and throw all their innards back out to the galaxy.
Exploding stars created us, most of the heavy elements in the stars around us, and the gas clouds the solar system dwells in. But it's a bad idea to be too close when a dying star explodes.
A supernova explosion is an incredibly powerful explosion. The core of the star bounces out and smashes into the outer layers and blows them out into the galaxy. So what actually happens is that material gets thrown out in a shock wave that, if you're near enough to the shock wave, would be destructive.
If it's 10 light years away or so, then high-energy radiation, like from X-rays and gamma rays, can harm us. It can, for example, destroy part of the ozone layer. What happens is the radiation comes in, disrupts nitrogen molecules. The nitrogen atoms then combine with oxygen to form nitric oxide. That nitric oxide, NO, disrupts ozone molecules, O3, and forms nitrogen dioxide, NO2. The nitrogen dioxide can then combine with atomic oxygen, forming more nitric oxide, which then disrupts more ozone, which leads to a snowball effect. So within a few weeks, you can destroy much of the ozone layer, allowing the sun's ultraviolet radiation to come in, and that would then kill life that's on the surface layers of an ocean or in ponds.
That death toll would include the phytoplankton that are the foundation of the marine food chain and provide 50% of the Earth's oxygen. And that would spell doom for most larger forms of life, including us. One candidate for stellar extinction lies outside the local bubble, although it's been a familiar sight for thousands of years. The red supergiant, Betelgeuse. The star, between 500 and 800 light years away and 20 times the mass of the Sun, forms the right shoulder of the constellation Orion.
Betelgeuse is getting near the end of its life.
Between 1996 and 2011, Betelgeuse shrank by 15%. For reasons that are still not understood. The red giant may go supernova in 500,000 years, or it may have already happened.
It's conceivable that Betelgeuse will go supernova tonight, or tomorrow night, or next week. But it's much more likely to become a supernova in 100,000 years, or in a few 100,000 years. Given that Betelgeuse is at least a few hundred light years away, it's possible that it's already blown up, and we just don't know it because the light hasn't reached us yet.
The good news is that even if Orion does dislocate its shoulder, Betelgeuse is too far away to harm our neighborhood. But then there's HR 8210, about 150 light years away in the constellation Pegasus. It's not one star, but two. A star and a white dwarf in binary orbit around each other. The white dwarf is about 15% more massive than our sun. Not at the supernova tipping point, yet.
HR 8210 is this binary system, two stars that are orbiting one another, one of which has actually already died and is a white dwarf. Now, this system has the potential that when the star that's very hot right now starts to go through its death throes and starts to puff up as it dies, it might start to pour material onto that white dwarf. Essentially, these systems are like zombie stars eating their companions.
When that normal star starts to expand, the white dwarf will start stealing material from its companion, becoming more massive. And if it reaches a certain unstable limit, it'll blow up as a Type 1a supernova.
Are we far enough away to avoid being collateral damage when HR 8210 explodes?
If you want to be completely safe from a supernova, you should be at least 100 light years away. 10 light years might be enough, but it might not. It depends on what effect kills you first.
But that won't happen for a really long time. And by then, we will have moved off, and it will have moved off, because everything in the galaxy is really on its way somewhere. So over time, that might happen, but at the point that it does, it probably won't be very close to Earth at all anymore.
But don't feel too comfortable. The threat of HR 8210 was only discovered in 2002. How many more potential supernovas are out there? How close are they to us? And how soon will they explode? To possibly make matters worse, some astronomers say that there are a lot more supernovas in our neighborhood's future.
Our solar system orbits our galaxy at a different rate than the spiral arms do. That means eventually we're going to enter a spiral arm. And because there's a lot more massive stars there, some of them will be ending their lives creating supernovae and posing a greater threat to life on Earth.
Still, our place in the Milky Way is secure for tonight, and for at least a few million nights to come. Plenty of time for more exploration and more surprises.
We live in a pretty diverse neighborhood, actually, and things are changing. The galaxy is not a static place, so it's going to be an interesting place to see in a billion years.